Hello, in this video we are finishing up our discussion of section 7.2 on volumes. We are concentrating in this lecture on the washer method because we are rotating regions around axis of revolutions which result in gaps or holes in the center of our solid of revolution so that our cross-sectional area is a washer. So in example 4, we have the region bounded by the curve y equals 4 minus x squared and the line y equals 2 minus x. It's revolved around the line y equals -1 to generate a solid, and we're going to find the volume of the solid. One thing that I want to point out to you before we continue is we're rotating around a line that isn't one of the coordinate axes. So this is going to make finding our inner and outer radius functions a bit harder, but we'll see how it is done in this example. So I'm going to walk through the same set of steps that we saw in the previous example. The first one is to sketch the region. So let's first draw y equals 4 minus x squared. This is a parabola that's opening down with a vertex at 0, 4. It will cross the x-axis. You can figure this out by setting y equal to 0. That's going to end up being 2, and then we would also have -2 back here. So we'll have the point 2, 0 and -2, 0. Other than that, we don't really need much more information for right now. We will need some intersection points once we sketch the line y equals 2 minus x. So the line 2 minus x is going to have a slope of -1. It's going to go through the y-axis at 2, and it will also go through the point 2, 0. So we're going to have something like this, y equals 2 minus x, and let me go ahead and label y equaling 4 minus x squared. So clearly we already have one intersection point at 2, 0. The other intersection point, if we wish to find that, we can set our two equations equal to each other. So 4 minus x squared is equal to 2 minus x. Rearranging, we will have x squared minus x equals, -2 equals 0. So we're going to get x minus 2 and x plus 1. So we have x equaling 2 and x equaling -1. So clearly one of our intersection points we already have. The other one is at -1, which will give us a y value of 3 there. So we have our two intersection points. We are asked to revolve around the line y equals -1. So that's going to be down here. So we are taking the region bounded by these two curves, so that's that one, and we're rotating it around the line y equals -1. So then our inner radius, we're going to start at the axis of revolution and draw a line segment up to our first boundary. That's going to be little r. Notice we're rotating around something parallel to the x-axis. So this is going to be a function of x. And then repeating the process, but going to the farther edge of our region, that's going to give us our outer radius, which will also be a function of x. So in words, big R of x, our outer radius, is going to be the distance between our axis of revolution, so that's y equals -1, and our red curve, so that's y equals 4 minus x squared. We're talking about a vertical distance, so that's going to be top minus bottom. Our top function is 4 minus x squared. Our bottom function is -1, so we're going to have 4 minus x squared minus a -1, which gives us 5 minus x squared. Little r of x, in words, is the distance between our axis of revolution, y equals -1, and our straight line, that is y equals 2 minus x. Oops, 2 minus x. Again, we'll have top minus bottom, so it's 2 minus x minus -1, which gives us 3 minus x. And our bounds of integration, the smallest x value in this shaded region is down here at this point, which is, mixing up my directions there for a second. The smallest x value is over here at x equaling -1. Our largest x value is over here at x equals 2. So we're going to integrate from x equals -1 to x equals 2. So our volume then is going to be the integral from -1 to 2 of pi big R squared minus little r squared dx. So that's going to be, let's pull the pi out, -1 to 2. Big R of x is 5 minus x squared. Oops. All of that squared. And then minus little r of x is 3 minus x squared dx. The easiest way to integrate this is to multiply everything out and combine your like terms. So we'll have pi times the integral from -1 to 2 of 25 minus 10x squared plus x to the 4th, and then we'll have minus a 9 plus 6x minus x squared, and there I squared out the 3 minus x and also distributed the negative. So we're going to have pi times the integral from -1 to 2 of, let's see if we combine our like terms, we're going to have x to the 4th, then we'll have minus 11x squared, then we'll have plus 6x, and then plus 16. So now we have a pretty simple polynomial. We can integrate this and plug in our bounds. We'll have 1/5 x to the 5th minus 11/3 x cubed plus 3x squared plus 16x. This gets evaluated at -1 and 2. And I'm going to spare the arithmetic. You plug in 2, subtract, plug in -1. You can do that on your own. You should get for a final answer 153 pi over 5. And just to be careful, let's label it with square units. And there is our volume of this solid.